It is more interesting to see what happens in part 3. Remember, in part 3 we have to see the formula for the external measure in the universal set x. So let me just start with the subset A of x. I will call B is the image of this set, and I will observe that the A will be a subset of the pre-image of B. And I also emphasize that it is not always true that you have the identity here. And that's a good example for if this blue polygon is your set A, if the blue polygon is a set A, the set B, the image of A will be this red interval underneath, and the pre-image of this set B will be this pink rectangle. That's the pre-image. So you see the image, the original A is a subset of this pre-image, pre-image of B, but it doesn't equal to it. So in general, you cannot expect equal sign here. Now, our job is to see that our job is to establish the identity for the external measure of this A, and look what I'm going to do. Fixing epsilon. By definition, there is a elements of your sigma semi-ring L, such that their pre-images produce a covering for A, because these are the elements of semi-ring S. Such that look what happens. Such that the sum of individual measures of this BNs, remember this by definition, this is the same as M of, these are the individual measures of the elements of this covering, and that's the inequality which comes from the definition of the external measure. Now what I claim is in fact that the B set, so because A is the subset here, the B, which is the image of A, will be a subset in the union of these BNs. That's what I claim. Why this is so? Because here we go. If I take an element y from B, this means that there is an x in A. Look at the definition of B, such that y equal f of x. This further means that because A is covered by this, there's an n, so there's an element in this covering such that x belongs to this element of this covering. Now, by the definition of the pre-image, this means that the y, which is f of x, belongs to the Bn, and this means that y belongs to the right-hand side, because right-hand side is a union of these Bn's. So I started with this, and I came down to this. That's why we have this embedding. So these Bn's, which originally were in the pre-image side covering for A's, they in fact also coverings for B. And by the definition of the external measure, but this time external measure G, for any coverings, external measure less than the individual sum, like this. So look what we came to. We came to the conclusion that the external measure of B less than the external measure of A plus arbitrarily chosen positive number epsilon. Pushing this epsilon to 0 proves the inequality like this. Now to finish the part 3 we have to prove the opposite inequality, and it's done even simpler than this one. This time, again, for this epsilon, I can find covering. Now this is a covering now in the semi-ring L, such that by the definition of it, the sum of the individual measures of this covering less than the external measure of V plus this epsilon. Now all I have to do now, I have to just observe that if I apply the pre-image to this embedding, the embedding will stay. So if I take A, which is a subset of the pre-image of B, it's set here, it will be a subset of union of individual pre-images. So this is just, I applied pre-image here, I applied pre-image here, which means that these elements produce covering for A, and that establishes this part of the inequality, because the external measure of A less than, it's monotonous, so the external measure of A is less than the external measure of this one, here it is, and because this is a covering of A by the definition of the external measure, this is controlled by this. And again, pushing this epsilon to 0, observe that we show that this number less than this thing, and neither left-hand side nor right-hand side measure here depend on epsilon, so you can push this epsilon to 0 and come to the opposite inequality. Combining these two inequalities establish the identity in part 3. That in fact this measure equal to this measure